Hi, Year 10. Now, the last lesson we had together as a class was on conditional probability, and there was a number of you away. So, for some of you boys, you've done this before, but for the boys who are away, this is for them. Okay, so we're looking at conditional probability. Now, in many practical situations, events are not independent. So, for example, the probability of a student arriving at school on time of catching a bus may be dependent on the amount of traffic. So we'll say those two events are dependent. Okay, so the first event is the student arriving at school. Okay, the second event is the amount of traffic. Okay, so student arriving at school on time, there's your first event there, and the amount of traffic, those are the two events. So one event depends on the other. Now, conditional probability is used to calculate probabilities of dependent events. Let's have a look at the first one. And I'm just going to go to full screen mode, so I've got more writing space. So view full screen. Okay, here we go. All right, so we've got a bag consists of 3 red marbles and 2 yellow marbles. So all together, you've got 5 marbles there. Now, 2 marbles are drawn from random from the bag without replacement. So you take the first marble out and you don't put the second one back. That's what that means. So what is the probability that the second marble is yellow given that the first marble is yellow? Okay, so let's think about this. I've got two yellow marbles. Okay, if I've taken one out, that means now I only have 1 yellow marble left. Okay, but I still have the 3 red marbles that I started with as well. Okay, so I've got 1 yellow, 3 reds, and that means altogether I've got 4 marbles. Okay, that means my second selection will be out of 4. So the probability of the second marble being yellow will be 1 out of 4. Okay, 1 out of 4. So a few too many lines on this page. Alrighty, so that's a conditional probability because the second selection was influenced by the first selection. All right, so let's have a look at the next question. Okay, now 2 dice are rolled. 2 dice are rolled. So we've got to use a table to show all the possible totals. So the first dice could show a 1 and the second dice could show a 1. So altogether that is a total of 2. Okay, and then the first dice could show a 2 and the second dice could show a 1. Okay, total of 3. And then that continues, total of 4, 3 and a 1, and you've got a 4 and a 1, 5 and a 1, 6 and a 1, and so on. Okay, now the next row, if you look, we could have a 2 and a 1 combining, couldn't we? 2 and a 1. So it gives you 3. And we could have a 2 and a 2 combining to give me 4. And that keeps going, 5, 6, 7, 8. All right, we just erase these bits here. Okay. Now, what's next? Let's use a different colour. So you've got a 3 next, so we could have a 3 and a 1. Right, that gives a total of 4. And then we get a 3 and a 2, total of 5, 6, 7, 8, 9. So you can see the pattern that keeps going. So let's go back here. And you're going to have 5 there, 6, 7, 8, 9, 10, and then 6, 7, 8, 9, 10, 11, and then 7, 8, 9, 10, 11, 12. Okay, so just remember it's the numbers combining together to get the totals. So 2 6s gives 12 as a total. Okay, all right. Now, given that the total is 7, so this is our condition, given that the total is 7, what is the probability that one of the dice shows a 3? So what we're going to do is we're going to go and highlight all the totals of 7. So let's do this. There's one, there's another one, here's another one. So these are all the 7s, okay? Now, think about this. How many 7s are there? Well, 1, 2, 3, 4, 5, 6, 7 7s. So if you come down to here, that means out of 7, right, we're selecting from 7 7s. And what is the probability that one of the dice shows a 3? Well, what you need to do then is go to the 3s column, okay? Where are we? We got not there. So you go to the 3s column here. So I'm just going to circle. So all the 3s there, and then I go to the 3 row. Okay. Here we go. All right. Now, I'm just going to get rid of this top part there and do that circle again. Okay. So all the numbers containing a 3. All right, so these are all the numbers containing 3. Now, all we've got to look at is how many of those numbers that contain a 3 are forming the 7. Now, you can see here that we've only got which one's in the circle column. So this one here, that will contain a 3, won't it? So that's going to be a 3 and a 4. Okay, 3 and a 4 makes 7. And then the other one that we've circled is this one. Okay, and that's a 4 and a 3. Okay, so out of those 7 combinations which make a total of 7, there are only 2 combinations which contain 3. So there's one combination, 3 and a 4, and there's the second one, 4 and a 3. So that gives us a total of 2 possibilities out of the 7. Okay, so another way of thinking about it is we wrote this down bit by bit. Right, what could I get to make 7? I could get a 1 and a 6. I could get a 6 and a 1. I could get a 2 and a 5. I could get a 5 and a 2. I could get a 3 and a 4. And I could get a 4 and a 3. So each one of these is a possibility to make 7. And the question says, what's the probability that one of the dice shows a 3? Well, the only 2 out of those 7 that show a 3 are these 2. Okay? So it's 2 out of 7. All right, given that one of the dice shows a 4, what is the probability that the total is 10? Okay, so let's just erase what we put on here. Get rid of that. Get rid of the highlighted bits. So it's very similar to the first question. Okay, now, there we go. All right, so given that one of the dice shows a 4, okay, so that means what we're going to do is we're going to go to where the 4s are. Okay, here we go. Now, I'm looking at, okay, so all these numbers here. Oops. So click back on the, press the wrong button there. Now, all these totals of the two dice contain a 4, and all of these here contain a 4. Okay, so given that one of the dice shows a 4, what is the probability that total is 10? Okay, so let's have a look at that. We just got to look at all the ones with 10. Okay, now, well, there's a 10 there, and there's a 10 there. Okay, so if you count them, how many possibilities are there? 1, 2, 3, 4, 5, 6 across, and 1, 2, 3, 4, 5 down. That's 11. Now, you can't count the 8 twice. You can only count it once. So it's out of 11 then. We'll scroll a little bit up. And, okay, so we are looking out of 11. Okay, so out of 11. Now, how many of those actually have 10 as a total? There's only 2. Okay, so 2 out of 11. So the condition is one of the dice shows a 4. Okay, and the probability that the total is 10 is the second event that we've got to find. So we circled all the possibilities with 4 on one of the dice, and then there's 2 of those which add up to 10. So it's 2 out of 11. Okay. Now, another way of thinking about that question is to just list all the possibilities again. List all the 4s. So you could say, you know, what have I got? I've got a 4 and a 1, a 4 and a 2, 4 and a 3, and so on. List all the possibilities, but you don't need to. You can just look at that table. Now, second question, or part D, should I say, given that the total is 6, what is the probability of a double? So the condition is the total is a 6. So we've got to find all the 6s in here. So let's just delete all the previous markings. Okay. Now, all right. Whoops, that was meant to be a 10 there. Okay, so just draw that 0 back in there. All right, so question is, given that the total is 6, what is the probability of a double? So let's find all the 6s where the totals are. Okay, so I'll just highlight those. All right, so here are all the 6s. This one, this one, this one, this one, and this one. So I've highlighted all the 6s. So now, scrolling back down, given that the total is 6, what is the probability of a double? So where is the double? Let's have a look. Okay, so the double will be, now where are we at? Double, we've got a double 3. So just, I'm going to find out where my pen's gone. Here we go. Double 3. So this is the only one which contains a double if the total is a 6. So count all the times we get 6 as a total. So we get 1, 2, 3, 4, 5. 5 times that 6 as a total, and there's only one of those cases which has a double, which is a 3. So it's going to be 1 out of 5. Okay, so if we scroll down here, this is 1 out of 5. Now, for the students who are away, I'll also post these notes. Now, next, given that a double is rolled, what is the probability of a total of 12? Given that a double is rolled, what is the probability of a total of 12? Okay, so let's go back to find all the doubles. Okay, so let's just delete the previous markings. Given that a double is rolled. Now, what are the doubles? Double is double 5. Yep, whoops. Don't want that. We want to keep that as the 10. Double 5. Okay, so that's a double. What else? Double 3. That's 6. Double 4 is 8. Double 6 is 12. Double 1 is 2. Double 2 is 4. So there we go, 2, 4, 6, 8, 10, 12. So how many have we got? We've got 1, 2, 3, 4, 5, 6. So we've got 6 possibilities to consider. So there's 6 doubles, obviously. And the question says, what's the probability that you get a total of 12? Well, there's only one total of 12. Here it is. So altogether, there is 1 chance in 6. Okay, so there you go. So 1 chance out of 6. Okay, what about a total less than 10? Given that a double is rolled. So let's go back to our doubles and see how many are less than 10. Okay, so, well, what have we got? We've got this one. That's less than 10. That's less than 10. That's less than 10. Okay, so we've got 1, 2, 3, 4 less than 10. So we come back to that, and it's going to be 4 out of 6, or 2/3. Okay, so 4 out of 6, which simplifies to 2/3. Okay, now, last 2 questions on the sheet. Explain why if you toss a coin and obtain head, then the probability of obtaining a head on the next toss remains the same. Well, what you'd say is the 2 events are independent. Okay, independent. All right, the two events are independent, comma. So the probabilities remain the same. Also, the probability of heads remains the same. Okay. Now, copy that down. Copy all of this down, actually, but going back to the top, remember, we're looking at dependent and independent events, and conditional probability only works for dependent events. So down here, the 2 events are independent, so the probability does not change on each toss of the coin. Now, last bit. Let's change colours here. Explain why the statement, if you obtain a tail on each of your 4 consecutive tosses of a coin, then there is a greater chance of obtaining a head on the next toss is incorrect. Well, it's pretty much the same as the previous answer. Okay. The probability of tails remains the same because the events are independent. So I guess that's what you'd be writing down here is the probability of tails remains the same since the coin tosses are independent events. Okay, great. Right, so that's pretty much it. Now, make sure all that's copied down onto your notes. And you're going to do exercise 1007, question 1 to 13. Okay, question 1 to 13 from exercise 1007. All right, thanks for listening. And we'll just stop that recording.